Hey everyone, it's Joe again. I was just going over this practice problem that I'd posed a few lectures back. Basically, it was asking if you had a circuit set up like so. I'll just call this Vx right here. If we had a circuit set up like so, and we had R3, that resistor right there, if that decreases, what else would decrease? Would the current through R3 decrease? Would the voltage drop across R1, would that decrease? Would the voltage drop across R3 decrease? Or would the power across R2, would that decrease? Well, basically, since we know that the power across R2 is just Vx squared over R2, we can answer that. The voltage drop across R3, well, I mean, basically it would be Vx minus 0 over R3, which is dependent upon itself. But would that also drop? So basically the voltage drop, I'm sorry, that's just the current. So let me let me fix that for you guys. The voltage drop across R3 is actually equal to Vx minus 0. So basically the voltage drop across R3 is equal to Vx. So all we need to see was what happens with Vx when R3 decreases. Does that also decrease? Does it increase? And then also the voltage drop across R1. So VR1 is equal to R1 times I1, which is also equal to Vs minus Vx. And then just the current through R3. And we can kind of think of that. That's just Vx over R3, which we already discovered earlier. Alright, so what happens? Let's just start with the current through R3. Alright, we're sitting here, we're thinking about this current right here. The current through 3. So if this is the relationship here, and we know that, say, for example, Vx is fixed. Let's just say it equals 1. And let's just say that R3 is equal to 1. So then you get 1 amp. Oh, what happens if it gets smaller than 1? Let's say it's 110. Well, the 10 will flip to the side here, and then you actually get a current of, I'm sorry, I'm not even writing that on the screen. Let's just say it's 1. Okay, now let's delete this, and we got 1 over, let's just say R3 is 1/10 now. It's getting smaller. Well, this 10 will flip to the top, and you get 10 amps. So we can definitely see that as R3 decreases, your current through R3 will increase. Alright, well, here's a visual of that. If we know that the current through R3 increases, we also know that we have a current that comes in, we'll call that one I1. We have a current that goes out, that's I2. Here's another current that goes out, that's I3. Alright, well, basically the sum of the currents should equal 0, or in other words, your current, your incoming current, or your supplied current, is actually going to equal to I2 plus I3. Or in other words, what comes in will equal what comes out. And since I1 comes in and I2 and I3 comes out, we know that that is the relationship. Okay, so in this case, we know that current through 3 goes up as R3 goes up, so we know this is going to get bigger. This one is basically going to stay about the same, because as this gets bigger, it will converge to what I1 equals. So I1 will equal about I3. So with that being said, that I3 goes up, so will I1, because it needs to be supplied from somewhere. So if you have like a huge current of here, that's going to equal to a little bit of that plus whatever R2 would be, unless this is R3. That's pretty similar to R1. And that's just a visual of how that will look. Okay, so with that being said, we know that your current 1 will go up. And since we know through current 1 goes up as R3 goes up, we know that the voltage drop across R1 also goes up. So if you think about it, R1 is constant. That's the same. It's never going to change. But I1 does go up with I3, which is only going up because R3 is going down. So the voltage drop across R1 is also going up. Now if we think about that too on this perspective, if this is the same and this is getting big, that means this answer, the voltage drop, is getting bigger. And the only way for the voltage drop to get bigger is if Vx gets smaller. So for example, say Vs is 10 volts, and then let's just say Vx is 1 volt, then you got 9 volts. And let's say it's 2 volts, now you got 8 volts difference. If it's 3 volts, now you have a 7 volt difference. If it's 4 volts, now you have a 6 volt difference. So basically what I'm saying is, in order to keep this overall number larger, Vx actually needs to get smaller. So Vx, while currents our I1 and I3 are going up, R3 is going down, and Vx, the voltage right here, will actually go down as well. And that will answer the rest of our questions. Okay, well, the voltage drop across R3, we had talked about that earlier, and we noticed that the voltage drop across R3 is Vx. Well, I just literally said that Vx is getting smaller as R3 is getting smaller. That means the voltage drop across R3 is getting smaller as R3 is getting smaller as well. So that's one question, and this one actually answers it. But let's see if the power across R2 drops as well. And to me, in order to get power, you need to have current. And if R3 is taking up more current from R1, then R2 would be getting less current. So to me, just right off the bat, R2's power is going to get smaller as R3 or I3 gets bigger. But another way to answer it is just as I stated here. We just said Vx is getting smaller with R3. That means that even though this is getting squared, each number of Vx with respect to R3, when R3 gets smaller, Vx gets smaller. So every time you square it, it doesn't matter. It's still going to be a number that's going to be smaller to the subsequent number that we just chose. So Vx is 4 volts, and then it's 3 volts, and then it's 2 volts. You can see how power across R2 is actually also going to get smaller. Well, there you have it. You have Vx getting smaller, you have the voltage across R3 getting smaller, you have the voltage across R1 getting bigger, the current in R3 getting bigger, the current in R1 getting bigger, and also the power through R2 would get smaller. If you guys have any questions, please post them in the comments. I might get back to you. If not, I would like it to be community driven, so if someone sees a question, they know how to answer it, and they feel confident about it, go ahead and collaborate. That's how you guys learn, is by collaboration. And I'll talk to you later. Bye.